All right, 6.2, solving exponential equations using properties of exponents. So this is very similar to the previous lesson, but now we're going to use our properties of exponents to solve equations. So we still need to know those properties, got to use them every time. But now we're trying to get it so that the bases are equal, because if the bases are equal, then the exponents are equal. So let me show you what I mean. Here I could see that these are two very different equations. But if there's some way I could get them to both have the same base, I could set the exponents equal to each other and then solve. So I want to think, is there some way that I could write 64 as an exponent with a base of 2? So this is where maybe a calculator would come in handy, or you think about what your exponents are, but 2 to the 6th power is actually 64. Again, I happen to know that, but if you didn't, you could just check in a calculator real quick. Just see, I would just put in 2 to the 3rd, 2 to the 4th, 2 to the 5th, 2 to the 6th, and see if you can get to 64. And sure enough, 2 to the 6th gives you 64. Okay, well, since we know that, we can actually rewrite all of this. We could say that this is like saying the exact same thing, 2 to the 3x minus 7 equals, but instead of 64, I could write it as 2 to the 6. And then it's still to the x power. Now, this is where our properties come in handy, because we know that we have an exponent to an exponent here, so we can just multiply. And so this is really like saying 2 to the 3x minus 7 equals 2 to the 6x. Okay, this is it. This is the whole idea, is now, see, remember, if the bases are the same, then the exponents are the same. Now we have the bases being the same here, so that means that the exponents must be the same. So we could simply say 3x minus 7 equals 6x. And this is a pretty easy equation to solve. I'm going to subtract 3x, and I'm going to get negative 7 equals 3x. Divide by 3, divide by 3. And it turns out that x equals negative 7/3. Now, it doesn't have to always be a nice, pretty integer. It could be a improper fraction like this, and that's fine. So x equals negative 7/3. Boom. We're done. All right, so practice number 1, very similar. I would say you're going to have to remember a couple properties, one of them being that when you have a 1 over a number, you can use the negative exponents to get the reciprocal. So I'm going to let you play with this one first, give it a try. If you get stuck, just give your best guess and then unpause the video when you're ready to check your work. Okay, so the first thing I recognize is that 27 is the same thing as 3 cubed, which is nice because I need to get this as a base of 3. So I got 3 cubed, but it's still on the bottom. Well, the other thing is that, remember, if it's on the bottom, I can make it negative and moves it back up to the top, or vice versa. If it's on the top, I can make a negative and move it to the bottom. So remember, the negative exponent gives us a reciprocal, so that's exactly what this is. Well, from there, I can see that now I have an exponent to an exponent, so I just multiply. So I went ahead and distributed this negative 3. I get negative 3x, and negative 3 times negative 2 gives me positive 6. And now I have the two sides of the equation with the same base. Therefore, the exponents are the same, and now it's just simple algebra. Just solve for the exponent. And we get x equals. Pretty straightforward. All right. What if it's a little bit more complicated? What if there's multiple parts? Well, still not a big problem, because we can get these all to match. Now, there's a few different ways you can manipulate this problem. We can get all of these to be bases of 3. It's one way we could do it, and probably the simplest. But I want to show you something here. Instead of seeing if we could break this down as an exponent of 3, is there any way I could factor out an exponent here to make this 3 go to an 81? Now, I already did a problem above where we got this, we wrote 81, where we could write 81 as 3 to the 4th. We could do that, and we could write this as 3 to the 4th, and we get them all in 3s. And if that works for you, that's fine. I'm just showing you another method you might have to use. And that is, here, I think that I could factor something out of all these. In fact, I could factor out a 4. And if I was to factor out a 4, it would look like this. 3 to the 4 times 2x minus 1. Well, remember, when you're multiplying exponents, that's the same thing as having an exponent to an exponent. So this is actually equivalent to 3/4 to the 2x minus 1. Okay, well, I did that because 3/4 is actually 81. And so I could say, hey, this is the same thing as 81 to the 2x minus 1. And now if I brought down all the other terms, we would see everything is in the term of 81. And that's super helpful. We have common bases. Now, before I move on, I just want to point out, again, this is not the only way to do this. Real quick, you might also see right here that you could write this as 81 is 3 to the 4th to the 2x minus 8. And you could write this as 3 to the 4th to the 9x plus 1. There's nothing wrong with doing it that way and then adding your exponents here and setting it equal. You could totally do that. I'm just showing you another method that you might have to use, another little tool that you might have to use. Now, at this point, we're not quite ready to set these all equal to each other because we need to have just one base on each side. We do have common bases, but we need to have one base. Well, when we have common bases, remember, we can just add these exponents. So this is the same thing as saying 81 to the 4x minus 9 equals 81 to the 9x plus 1. At this point now, we do have two equations, two sides of the equation with the same base. Therefore, the exponents are equal. And so we could say 4x minus 9 equals 9x plus 1. And we can solve from here, subtract 4x, subtract 4x, subtract 1, subtract 1. And I get negative 10 equals 5x. And divide by 5, x equals negative 2. Okay. All right. I wanted to show you that way just because in the previous problems, remember, I broke it down to the lowest base, which is fine. Like here at 64, base of 2, 27, base of 3. And that will work. That would work here as well. But again, if you can factor out an exponent, you might actually be able to raise the base to match the other ones. That's a tool you might have to use. Okay, so that being said, I'm going to let you try practice number 2. Remember what it means when you're dividing. It doesn't look like you're going to be able to factor out a nice, neat number out of both of these, so that trick we used last time isn't going to work. But remember, when you are dividing with common bases, you subtract. So that may be your first goal here, is to get common bases on this side. So, and you subtract the exponents once you do that. So go ahead and give this a shot, and then check back and see what you did. Okay, quite a few steps in this one, but it's not really that bad. They're all pretty simple steps. The first thing I saw is that I could write 16 as 2 to the 4th, and if I do that, that means I can just multiply. So I distribute that 4 and I get 4x plus 20. Now I have the same base on top and bottom, which means that I can subtract exponents. So 4x minus 7x and 20 minus 2, because those are like terms. 4x minus 7x gives us negative 3x, and 20 minus 2 gives us 18. And since the bases are now equal on either side, we could set the exponents equal to each other, which is what I did here, and then I solved for x, and I got x equals 5. Okay, so hopefully we're trying to see a little pattern here. You're trying to get common bases, simplify it down so that there's the same base on both sides of the equation, then solve. All right, now we got the last couple here are a little tricky. On these ones, you'll notice that there's no way to write, there's 16 to an exponent isn't going to work, or at least an integer exponent, and 64 to an exponent isn't going to work. But maybe we could simplify these both down to a common number. So I'm trying to think, what is a number that I could write as an exponent that goes into either one of these numbers, just on the bottom for now, and I'm thinking 4. This is 4 cubed, and this is 4 squared. So let's just go ahead and do that. We're going to try and get to common bases of 4. So I got 1 over 4 cubed, negative 2x plus 4, equals 1 over 4 squared, 5x plus 2. And now remember, if it's on the bottom, I can get the reciprocal by just making the exponent negative. So we can actually get this even closer. We could say this is like saying 4 to the negative 3 to the negative 2x plus 4 equals 4 to the negative 2 to the 5x plus 2. Hope you're seeing how important it is to be very fluent in your exponent properties here. You really need to know them in order to do these types of problems. So let's go ahead and distribute. If we distribute this negative 3, we're going to get 4 to the positive 6x and the negative 12 equals 4 to the negative 10x and the negative 4. All right, we got common bases. That's what we were trying to do. So now we could set the exponents equal to each other. So I got 6x minus 12 equals negative 10x minus 4. From here it's a pretty simple algebra problem. Let's add 10x. Let's add 12. Cancels that, cancels that. 6x plus 10x is 16x. 12 and 4 is 8. Divide by 16, divide by 16, we get x equals 1/2. 8 over 16 reduces down to 1/2. There we go. Okay, so remember, got to know your negatives, got to know your exponents, got to know that you can multiply and distribute here when you have an exponent to an exponent. I'm just using my rules fluently. I'm very, very familiar with those rules, and that's how I'm going to be able to attack these problems. If I'm not familiar with those rules that I discussed and I reviewed in 6.1, these are going to be troublesome for you. So make sure you really know those. Make some flashcards or something. All right, last one here. Again, you can't write 8 as an exponent of 4, really. You could if you use fractional exponents, but we're not going to do that. So you're going to need to try and find a common base here and then solve for x. So I'm going to let you go ahead and give that a shot, and then I'll come back to you when you're ready. Also, this should have been practice 3, and the last one should have been, yeah, the last one's example 3. So go ahead and give that a shot, and then check with me when you're, check back when you're ready to check your answers. Okay, hopefully you saw that you could write 8 as 2 cubed and 4 as 2 squared. Then you could distribute this exponent to an exponent, so you get 9x minus 21 and you get 12x minus 2. The bases are now the same, so you can set the exponents equal to each other, do some algebra and solve, and I get x equals negative 19/3. Now it's not a nice pretty number, but that's okay, it still works. And that's all we really care about here. Okay, that's it for this video. I'll see you guys on the next one.